What is the subglacial environment beneath polar ice? Imagine a world hidden beneath miles of ice, completely dark and frozen, yet teeming with activity. That's what scientists call the subglacial environment. It's the space right at the base of glaciers and ice sheets, where ice meets bedrock or sediments. This zone can stretch over vast areas, especially beneath the Antarctic ice sheet and Arctic glaciers. In fact, the Antarctic subglacial system covers an area roughly the size of the United States. Beneath this ice, there are lakes, water channels, and sediments that form a complex, dynamic system. Water is the key ingredient here. It comes from melting caused by heat from the Earth's interior, friction from ice movement, or surface meltwater that seeps down through cracks and moula. This water interacts with rocks and sediments, dissolving minerals and carrying suspended particles. The pressure at the bottom of the ice can cause melting even when the surface is freezing. In some glaciers, especially those with warmer ice at depth, the pressure melting point is reached, creating a thin layer of liquid water. This water acts like a lubricant, helping the ice slide over bedrock or sediments. It also forms lakes beneath the ice, like Lake Whillans in Antarctica, which exists in total darkness at -0.5 degrees Celsius under over 800 meters of ice. These lakes are identified using radio echo sounding, which detects smooth, mirror-like reflections from the water surface. There are at least 120 for active subglacial lakes in Antarctica alone, and they change in size and position over months or years. When these lakes drain, the ice can slow down or speed up, affecting how fast the ice sheet moves. Water flows through channels and tunnels, forming a drainage system that responds to seasonal changes and meltwater input. Despite the extreme cold and darkness, microbial life exists here. Microbes have been found in basal ice and subglacial lakes, where they survive by chemical reactions rather than sunlight. They relying on organic material from soils or other sources, and some microbes actively reproduce in these environments. The chemical makeup of subglacial water is very different from surface meltwater. It has high concentrations of dissolved minerals and suspended sediments, which record the conditions at the ice-bed interface. These environments are important for understanding how ice sheets respond to climate change. As polar regions warm, more meltwater is produced, increasing subglacial water flow. This can accelerate ice loss and contribute to rising sea levels. The injection of freshwater into ocean systems also influences ocean currents and ice shelf stability. Studying these hidden worlds helps scientists learn how ice sheets behave and how life can survive in the most extreme conditions on Earth.